Hi, I'm Sean Reagan. I'm technical editor with Make. Today, I want to show you how to build a light-seeking beam robot that uses just a handful of simple components to produce a surprisingly complex behavior. This little robot uses a simple power amplifier chip and two light-detecting eyes to follow the brightest light it can find. It's a great example of beam robotics, which is inspired by biology. Rather than relying on complicated microprocessors, programming, and digital logic, beam robots favor simple components, responsive control systems, and analog logic. So what does that mean? Basically, beam robotics is about getting the most complex and interesting behaviors you can using the simplest possible components. It can be pretty challenging, but it can also be lots of fun. You'll need an afternoon, some soldering skills, and the following parts to complete this build. You can head over to your local Radio Shack, where you can pick up all the electronic components you'll need. You'll also need the following tools. Before we get started with the build, let's go over how the circuit works. At the core of our circuit is the LM386 power amplifier chip. We can think of the chip as a black box, with inputs and outputs that respond in predictable ways. It's able to compare the voltage levels coming in from the two light sensors on pins 2 and 3 and trigger the motors to turn toward the brightest source. The key is pin 5. When one eye sees light, pin 5 acts as a current sink, and only motor number 1 is powered. When the other eye sees more light, pin 5 acts as a current source, and only motor 2 is powered. We'll start by building the power system, which consists of 2 battery holders and 2 switches wired in series. A master power switch, and a tail dragger roller switch that cuts the power when the robot is not resting upright. Remove the threaded ears from the ends of the slide switch by bending them back and forth with pliers until the metal fatigues and breaks. Next, clean the back of one of the battery packs and the sides of both switches with rubbing alcohol. Use double-sided foam tape to secure the switches to the battery pack. Center the roller switch along the bottom edge and put the slide switch in the upper right. Cut, strip, and solder the red battery pack lead to connect the 2 switches in series. Use the leftover wire to make 2 leads attached to the master switch's remaining terminal. Then, cut the red lead off the other battery pack at the point where it connects to the terminal inside the battery holder. Now we can finish up building the body of our robot. Apply additional foam tape to the exposed sides of the 2 switches. Route the wires so that one red lead goes out the side and one goes out the top. Then thread the black wire into the second battery holder. Then attach the battery holders back to back with the switches sandwiched between them. Clean the front side of the body with rubbing alcohol. Then cut and apply a piece of Superlock fastener tape to fit it. Cut, strip, and solder the black lead to the battery clip terminal where you just removed the red lead earlier. This connects the 2 battery holders in series. Now our bot needs some legs, or rather, some motors. On each motor, clean the side that has no vents, then apply 2 small strips of Superlock fastener tape. Use a sharp hobby knife to cut 2 fresh pencil erasers off right at the ferrule. Stab one eraser onto each motor shaft to serve as the wheel. Attach the motors to the front of the body using the Superlock tape. Attach the front red lead to the outboard terminal on the starboard or right motor. Attach the black lead to the inboard terminal on the port or left motor. Attach a second black lead, made from leftover battery holder wire, to this same terminal. Finally, attach a lead to each of the 2 remaining motor terminals. These will both connect to pin 5 of the integrated circuit. Next, we'll build the bot's head, which will hold its eyes and brain. We'll start with the eyes. Cover the leads of both IR detectors with heat shrink tubing except for the very ends. The leads function as maneuverable eye stalks, and the insulation keeps them from shorting if they get bent or twisted together. Next, solder the brain, or LM386 integrated circuit, resistor, LED, and a black jumper wire to the PCB as described in the schematic. You can find the circuit diagram and detailed descriptions of how it works on the project page. The last step is to run the loose wires from the motors into the body, then back up out the top. Cut, strip, and solder the remaining 4 wires to the PCB. Power, red, black, ground, and the 2 shared motor leads, green, should be attached as shown on the project schematic. Apply double-sided foam tape to the bottom of the PCB and attach it to the top of your bot. Now install the 4 AAA batteries. Find a sunbeam on a smooth floor, flip the slide switch forward, and set your completed bot down on it. If everything is working right, the robot will come alive when the roller switch presses down and will speed off happily in search of the brightest light in the room. It's easy to adjust the angle of the motors on the front of the body, which will affect the speed and power of the robot's drive system. A steeper, more vertical angle will drive slower but stronger, while a shallower, more horizontal angle will be faster but weaker. You can also adjust the bot's stance by bending the roller switch. The IR detector eyes can be adjusted left, right, up, and/or down to bias the bot's steering in one direction or the other. A bot that prefers turning one direction or the other can often be corrected just by adjusting the eye stalks to compensate. What about adding or using other components in your bot's circuit? Reach into your junk box and pull something out at random. How can you hack it to add interesting behaviors to your own Beam robot designs? As always, we'd love to hear about your creations in the comments section of the project page.